Hello everyone. Once again welcome to PM Networking. Hope you all are doing great. Guys, today in this video we are going to understand how to configure dual ISP failover. How to configure dual ISP failover. As you can see, this is my scenario for today. Right, in this scenario, this is my LAN network, private network, inside network, you can say, and I have connectivity from two different ISP, from ISP1 and ISP2, and ISP1 is my primary ISP, ISP2 is my secondary ISP, right? So guys, my requirement is, you know what, my requirement is whenever these LAN user want to access internet, router 1 should forward traffic of LAN user towards ISP1 if ISP1 is up. Means until ISP1 is up, available, router 1 should forward all traffic towards ISP1. But in case if ISP1 is not available, ISP1 is down or failed, then R1 should shifted all traffic towards ISP2 automatically. Right, what I am saying, until and unless ISP1 is up, router 1 should forward traffic towards ISP1. If ISP1 is down, then router 1 should forward traffic towards ISP2. Means router 1 should we will configure the scenario so that router 1 can shift the traffic from ISP1 to ISP2 automatically if ISP1 will goes down. So what we need to do, we need to track ISP1 as well, right, from router number 1, so that until and unless this router is able to track ISP1, it will forward traffic towards ISP1. If ISP1 is not available, then router 1 will forward traffic towards ISP2. So see the configuration from the scratch, right, how I will configure this scenario. So I have console of these all devices. You can see this is console of router 1, PC1, PC2, ISP1 and ISP2. On ISPs, I have already configured IP addresses. So you can check on ISP1, I can run show IP interface brief, exclude unassign command. You can see IP address on serial 2/0 is 15.1.1.2. I am using 15 network between R1 and ISP1. I am using 16 network between R1 and ISP2. 15.1.1.0/30 and 16.1.1.0/30. These are my public IP address. Fine. And I have one loopback on ISP1 where IP address is 8.8.8. In the same way on ISP2 also you can verify IP configuration. So IP interface brief exclude and assign. So you can see here on serial 2/0 IP address is 16.2 and on loopback IP address is again 8.8.8. Line protocol of this interface is done because I have not configured router number 1 till now. So by default router interfaces are done. Because of that you are able to see line protocol of this interface is done. Once I will run a no set command on router number 1, line protocol of this interface will come up. Okay, so let's begin the configuration of router 1, guys. First of all, see on router number 1, so IP interface brief, I have not configured any IP address on any interfaces of router number 1. So I'm going to configure router 1 from the scratch. So let's begin. On router number 1 interface serial 2/0, first of all I will configure IP address here. I will run ipnet outside command and I can put some description as well. Description connected, this interface connected to ISP1, let's say ISP1, and then IP address 15.1.1.1 255.255.255.252, and then say ipnet outside, and finally say no set. Okay, this is configuration on serial 2/0. If you want to verify, do so run interface serial 2/0. So you can see the configuration of serial 2/0. I have configured one description, IP address, ipnet outside. That's it. Let me do same configuration on fast ethernet on serial 2/1 also. Interface serial 2/1. Say description connected to ISP2 IP address 16.1.1.1 255.255.255.252. Say ipnet outside and finally say no set. Done. Now I need to configure IP on LAN interface. So let me configure IP on LAN interface fast ethernet 0/0. Here also I can put description, let's say LAN, and then IP address 10.1.1.100. I'm going to use this network in my LAN 10.1.1.0/24. So IP address is on this interface is 10.100 255.255.255.0, right? Then IPNet inside, this interface is inside, and finally say no set. Okay, so this is basic configuration on router number 1, IP configuration you can say, right? Now I need to create one access control list, as you know, to define source. So let's say IP access list, standard name is, let's say, NAT, right? Here I am going to say permit 10.1.1.0 0.0.255. Done. Exit. I have created one access control list. Do so access list, do so IP access list. So I have access list with name NAT, and here I have defined source network. Now I am going to create a route map. Here route map, and name of the route map is, let's say, I will create two number of route map, one for ISP1 to match interface and source address. So let's say route map ISP1 permit sequence number 10, and here I am going to say match IP address from access list NAT, and then match which interface, serial 2/0 for ISP1. Exit. Now I need to create one more route map. Let me give name ISP2 to this route map. Again permit sequence number, let's say 10. Here also I am going to say match IP address from access list NAT and match interface serial 2/1, which is connected with ISP2, right? So I have created two route map. Do so route map. Okay, so first route map is ISP1, right, where I have defined match IP address from access list 9, and it will match interface serial 2/0. And another route map is route map ISP2 sequence number 10 permit with permit statement. Again it is going to match IP address from access list NAT, and it will match this interface. Okay, now I am going to configure NAT. So to configure NAT, you need to run this command IPNAT inside source, and I am going to match source from route map. So say route map, name of route map is ISP1, and then we can say interface serial 2/0 overload, right? So it will translate private IP address into the public, which is into the public IP address which is running on serial 2/0, right? I need to do same thing for ISP2, IPNAT inside source route map, name is ISP2, and interface serial 2/1, say overload. Done. This is route map configuration. Okay, now if you will ping, do ping 8.8.8.8. See, ping is not working because we don't have any default route here on this router, right? So I need to configure default route. Before configuring default route, I am going to configure SLA to track ISP, IP SLA to track ISP. So let me create one IP SLA here. Say IP SLA number 1, and what I can do to to track ISP1, I can track the IP address of this interface also. I can track IP address of this interface also. I can track 8.8.8 also, but 8.8.8 should be reachable from router number 1. Or what I can do, I can create one loopback also on router number, on ISP1. Let's say one more loopback 1.1.1, and I will track this loopback IP address, right? Until and unless this IP address is reachable from router number 1, that means my ISP1 is up. Okay, I can track this interface IP address also. I can track 8.8.8 also, and I can create one a specific loopback for tracking ISP1 as well. Okay, so let me do one thing. Let me create one one loopback interface on ISP1 for tracking. So on ISP1 interface loopback, let's say 10, and I am going to define IP here 1.1.1, let's say 255.255.255. So I will track 1.1.1 from router number 1 until and unless router 1 is reachable to this IP address, right? It will forward all traffic towards ISP1. If router 1 is not able to access this IP address, automatically router 1 will shift all traffic towards towards ISP number 2. Okay, so because of that, I have created this loopback on ISP1. Now again go to R1 and IP SLA1. Here I am going to say ICMP equal to 1.1.1, and from source interface we can say source interface serial 2/0. So from serial 2/0 router 1 is going to ping this IP address. Okay, this IP address. Here I can define timeout, let's say 5000, and frequency is 5. Okay, then here I can schedule the IP SLA by running command IP SLA schedule number 1 and life, let's say forever, and when you want to start this word IP SLA. So let's say now I want to start it now. So start time now. Done. Now it will start tracking 1.1.1. Okay, 1.1.1. So here, you know, to track 1.1.1 there should be one route, right, in the routing table of router 1 for 1.1.1, or there should be one default route, right, towards ISP1. So what I am going to do here, I am going to configure one, let's say static route, IP route 1.1.1 255.255.255, and then we can say exit interface is serial 2/0, and we can define next hop IP address also 15.1.1.2. Done. Now let me check I am able to ping 1.1.1 or not. Do ping 1.1.1.1. So you can see I am able to ping 1.1.1. So let me configure one here default route, IP route 0.0.0 0.0.0. Next hop is, let's say 15.1.1.2 towards ISP1, and I am going to use track number 1 for this default route, right? So until and unless this track 1 will be up, router will install this default route in their routing table. Now do so IP route. You can see there is no any default route available, right, because my track is down. Do so track, because sorry, do so IP SLA summary. So you can see my IP SLA is working fine, right? My IP SLA is working fine. So here I need to create one track 1. I have used track 1 with default route, so let me create track 1, and then we can say IP SLA number 1 and reachability, right? So if the 1.1.1 is reachable from here, track will be up. So soon track will come up. Do so track. So you can see track is up, reachability is up. Now if you will check routing table, do so IP route. So you can see we have one default route. And next hop IP address is 15.1.1.1. Now can I ping 8.8.8? Ping 8.8.8. Yes. And from the LAN interface, means my LAN user can ping or not. Source fast Ethernet 0/0. Yes, LAN user are also able to access internet. You can see PC, from PC number 1 also I can ping IP 10.1.1.1/24 and 10.1.1.100 is gateway. Now from PC 1, let me show you. PC 1 is able to ping 8.8.8 or not. Ping 8.8.8. Yes, PC 1 is able to ping, right? And if you will trace route 8.8.8 from PC 1, right, traffic is going via ISP1. Trace 8.8.8. So you can see PC is forwarding traffic to router. This is IP address of router, and then 15.2 is means towards ISP1. Now we need to configure failover. So on router number 1, I am going to define one more default route, IP route 0.0.0 0.0.0, and we can say next hop is 16.1.1.1 means towards ISP2, and here I can define higher AD value, let's say AD value 10 over here. So do so run section route. In the running configuration we have two default route. You can see two default route, one with track. So until and unless this track will up, right, router will install this default route in their routing table means towards ISP1. But if track will goes down, router will install this default route in their routing table towards ISP2. So for now, do so IP route. You can see in the routing table we have default route towards ISP1, right, because my track is up, okay. So now if you will ping, do ping 8.8.8 and source F0/0, you are able to ping 8.8.8 through ISP 1. Now let's say ISP1 is not available or ISP1 is down. If I will down interface serial 2/0 2/0 say shutdown and do so IP route. Now if you will, you can see the log message. Soon track will also down. You can see track is down now. Track is down. Okay, and so IP route. Now you can see in the routing table, router 1 have installed this default route, means now default route is towards ISP2. So again if I will ping 8.8.8 and say source fast ethernet 0/0, you can see I am able to ping. But again from PC number 1, if I will trace route, so you can see now my traffic is going to ISP2, towards ISP2, right? And again ping 8.8.8 and let's say -a, so you can see I am able to ping, right? So I actually now I am able to ping 8.8.8 towards ISP2 because my track is down on router number 1. Do so track is down. But if again track will come up, if I will run sorry no set command here, again track will come up and you can see ping is still working. Ping is still working. Now I am pinging 8.8.8 towards ISP1 because my track is up. Do so IP route. You can see in the routing table now default route is available. Default route is there towards ISP2. Just wait, soon it will update. Yes, now you can see default route is towards 15.2 and on PC number 1 you can see ping is still working fine. Ping is still working fine. But on real devices here, whenever ISP1 will goes down, so definitely router 1 will use default route towards ISP2, but you have to run clear IP NAT translation command every time. So let me do some automation on this router, right? For that we can run command event manager applet, and we can say name clear, let's say NAT, this is my NAT name, and then we can say event track 1 state down. If track state is going to down, right, then apply this action 1.0 and CLI command enable, and then I can say action 1.5 CLI command. We can run this command, right? Clear IP NAT translation star, like this, right? So whenever track will goes down, automatically R1 will run this command clear IP NAT translation. Okay, so this command is here available, clear IP NAT translation star, right? Now you can see ping is working, right? And if you will trace route, trace 8.8.8.8, so router 1 is forwarding traffic towards ISP1 because track is up. So again if I will run no set command, sorry shutdown command on serial 0/0 say shutdown, and if you will again trace route 8.8.8 from here, so you can see now my traffic is going via router via ISP2, right? Router 1 is forwarding traffic towards ISP2. Again if this interface will come up, so track will come up, and on track will come up, it will install default route towards ISP1. So here you can track again, just wait, in 5 seconds it will change the next hop. Now you can see next hop is 16.1.1.2. okay, so this is how we can configure dual ISP failover. Now guys, if you have any question, please let me know in the comment section. If you have learned something from this video, then please hit on like button. We will meet soon in next video. Till then, stay safe. Bye bye. Thanks for watching.